So a regression is when you use the relationship between variables as a basis for prediction. So we're taking correlations a step further. We're not just saying that these two variables are correlated, but we're saying they're correlated, and can we use one to predict the other? So if you see things about using variables to predict the other variable, you know you're talking about a regression. And in this course, we're just going to talk about simple linear regression, where we examine two variables that are linearly correlated and look at whether one can be used to predict the other. A simple linear regression has assumptions. It requires normality of data, homogeneity of variances, so remember that's where we use that Levene's test, and it requires that our dependent variable is on the interval or ratio level. And what it gives you in the output is a regression line. So this is going to take you back to old math classes. So a regression line is what you're going to get out of the output, and that is going to help you with predictions. So in the regression line, your y is your dependent variable, your a is a constant that you're going to get from the output, your b is a slope that you're going to get out of the output, and your x is your independent variable. So we'll go through an example and I'll show you where you get each of these numbers. Let's say that a researcher wanted to study whether subjects' income could be predicted by their years of education. So in this, you'd know that first you want to see, are the two things related? Are income and years of education correlated? And if they are correlated, then we want to take it a step further and do a regression and see if education could actually be used to predict income. And so we know it's regression because of that prediction component. So first we're going to develop our null and research hypotheses. These would be that education cannot predict income. That's our null hypothesis. And our research hypothesis is that education can predict income. And choosing our level of significance and what statistical tests to use. We're going to choose a level of significance of 0.05, and we're doing a simple linear regression. And then we run the test and obtain our statistics from SPSS. Okay, so we get several tables of output in our linear regression. The first table we get is the model summary. What this gives us, the R gives us the correlation coefficient. So remember, this ranges from +1 to -1. Let's see, our R is 0.76, so it's positive. So we know we have, as years of education go up, income level goes up, so they're positively related. And it's kind of a low to a medium correlation, strength of the correlation. R squared tells you the coefficient of determination. And what this is the percent of the variance in the dependent variable that could be explained by the independent variable. So in this example, it is 14.1%. So you just move your decimal point over 2 spaces to get a percent. So 14.1% of the variance of the variability in income can be explained by years of education. So that's not a huge percent, but we can find out if it's statistically significant or not. The next table that comes in the output generally is an ANOVA table, and this looks at how reliably the independent variables overall predict the dependent variable, and that gives you your p-value. So in this, our p is 0.015, which is less than 0.05. So it is statistically significant overall that the independent variables predict the dependent variable. And more importantly than that last table is this final table, and this gives you your coefficients. So in a simple linear regression, when we're just looking at one independent variable, our p-value is going to be the same, so 0.015. If we are looking at a more complex regression where we have several independent variables, in the ANOVA we're going to get the effect of the overall independent variables, and then in this coefficient table would be a row for each of the individual independent variables. So in this one, you don't look at the constant row, you look at the row that gives your independent variable. So remember, our independent variable is years of education, so we look at that row and move it all the way over to the p-value to get a p of 0.015. And then we need to fill out our regression line formula. So we do this, remember we keep our y there, equals, and then we have our constant, and for these we're always looking at the B column, our beta column, and the constant row gives you your first number, so that's a negative 9473.852. And then if we look in the row for our independent variable, we get 3349.145, and that gives us our slope of the line, and then we always leave our x there. So that gives you your equation. So in this equation, we got those two numbers, the constant and then the slope from the B column, and our x would be the education level and y would be the income. So making a decision about rejecting or failing to reject the null hypothesis. Since our p is less than our level of significance, we reject the null. So the null was that education cannot predict income. So if we reject that, if we throw it out, we know that education can predict income. And then we provide our regression line. And finally, we make a conclusion. So we would say the results indicate that education is a significant predictor of income, with education accounting for, and we go back to our R squared, 14.1% of the variability in income. And then I wanted to show you what that regression line formula gives you. So that gives you your ability to predict one variable from the other. So that's what we got out of our data. And then let's say, okay, well, what does that really mean? What if we had a subject that had 14 years of education? What does that mean for them? So what you would do is you could plug 14 in for x. Remember, x is our years of education. And so underneath I show you this. So we'd times 14 by 3349, and we'd get that. And then adding those together, we get $37,414.18. So that would be the y. That is the annual income, kind of the average annual income for someone with 14 years of education. Then you could say, okay, well, let's say we had someone with 20 years of education. What would we think their income would be? And you'd plug 20 into that equation and calculate the y. So the regression equation really gives you a way to calculate your prediction of the dependent variable based on knowing the independent variable.